Morning, guys. Um, we are on our last section for logs right here. So we're going to solve them. So remember with solving, it's about what X value, or depending on what variable you're using, makes it true. Some of the things we have to think about are domain restrictions, specifically with logs. Remember, so if you think of the grapholog, right, in the asymptote, it starts at the y-axis. So we have to make sure that our domain is greater than 0. So those will help us out as we solve. You'll see where that comes in. Make sure you show all your work and your steps so you understand how to get x by itself so we can actually solve for what values make the statement true. So let's use what we learned all this chapter to help us solve. We're wanting to say what x value here makes it equal -1. So we're going to get x by itself. So let's work backwards here. Okay, we have log by itself right here. So now we need to get rid of the log. Log base 4. Well, we can get rid of that by doing base of 4. And whatever we do to one side, we do to the other. Okay, so these two cancel. And we're left with x minus 5, I guess I didn't need the parentheses right there, equals 4 to the -1. All right, before I move that 5 over there, what is 4 to the -1? Well, 4 to the -1 is our fraction, right? So we have x minus 5 equals 1/4. Now, how do you get x by itself? We add 5 to both sides. I get 1/4 plus 5, which of course we can do this together, right? 5 as a fraction over 4 would be 20/4. So this would be 21/4. And again, if I put that in there, we have a good domain, so I don't have to worry about domain restrictions. And here's our answer. X equals 21/4. Okay, example 2. Let's actually put together what we did last time. Now, here we cannot get rid of the ln's for the fact that we have 2 of them on the left side. So we have to condense it to be able to get rid of the ln there. So remember, when we have addition here, what does that mean? That means multiplication. So we have ln of x minus 3 times x plus 4. So we need to condense it so we can get rid of that ln. Now, here's the other thing we need to watch out for. Well, this 3 in front is a problem. If you remember from a last section, when we have that coefficient on front, where can we move it? We can move it as an exponent. And now we see that to get rid of the ln's here, we can e both sides. Whatever we do to one side, we do to the other. Now, we're still solving for x, so let's remember what we have to do to put things together, take them apart, get x by itself. So here we have 2 binomials multiplied by each other. So let's multiply that out. Some of you might multiply it by our box method. Some of you might do FOIL. You do whatever you need. But what we should get when we multiply that out is x squared plus x minus 12, and then equals, and 2 to the 3rd is the value of 8. Now we still have to be able to solve for x. So what I'm going to do now is move that 8 over. I get x squared plus x minus 20, because we're subtracting the 8 from both sides, equals 0. Now we have it set equal to 0 so we can factor it and solve. So when I factor this out, again, do it how you need to with your box method, do whatever you need. I'm going to do it quickly because I'm focusing on solving for x. When I factor this, I get x plus 5 times x minus 4. Again, do your own factoring strategy. equals 0. So what makes these values equal 0? Well, x is -5 and x is +4. Now, this is where our domain restriction comes into play. We need to make sure that both of these values work before I say this is my answer. Well, if I plug -5 in here, -5 minus 3 is -8. I cannot have ln or log of a negative number. So x equals -5 does not work. Let's check our 4. Let's see. 4 minus 3 is 1, so that's good. 4 plus 4 is 8, so that's good. So our only answer is x equals 4. Sometimes we'll have both answers. Sometimes we'll only have one. Sometimes neither of them work. So we have to check those solutions to make sure they fit in our domain. All right. I love this example because you think we're going to do something difficult, but as you can see, the bases are already the same. Now, mathematically, I'm going to show you how they go away instead of just making them go away. So we have the same bases, so we're all good. How do you get rid of a base 2? Well, we log base 2 both sides, because then those bases cancel, right? And we're left with x plus 3 equals 2x minus 9. Now, this is old school, right? Going back to our move the x's to one side and everything without an x to the other. I'm going to make it so I have a positive x because I like working with positive x's. So I'm going to move this x over by subtracting it, leaving me with 3 equals x plus minus 9, sorry. Jumping ahead. How do you get rid of that 9? I add 9 to both sides. So we get x equals 12. Now, you can double check. You can plug this in on a calculator and make sure. So this is 2 to the 15. 25 minus 9 is also 15. So both sides would be 2 to the 15. That's the great thing about solving. You can always grab your solution, plug it back in, and check your answer. Now, as you can see in this case, our bases are not the same. So before I get rid of that base 3, I have to make sure that our bases are the same. Well, so what's the connection between 3 and 9? Well, 3 squared is 9. So I'm going to change that 9 there to a 3 squared. Now, we already had this x minus 1 up here. And an exponent to an exponent means multiplication. So that's why I multiplied it right here. And I'm going to expand that out before I get rid of the base 3. So we get 3 to the 2x minus 2. Now, we can get rid of the base 3 by log base 3. Whatever I do to one side, I have to do to the other. We have x plus 1 equals 2x minus 2. And then solve just like we did before. Move the x to one side. So I get 1 equals x minus 2. Add 2 to both sides. We get 3 equals x. Okay, now you can plug both of those into your calculator and double check. There we go. All right, 2 more. Log base 2 of this big thing equals 3. All right, well, log, there's nothing on the outside of log on the left side there. So I'm going to get rid of log base 2 by base 2. Whatever I do to one side, I do to the other. These two cancel. I'm left with x squared plus 8x plus 23 equals, well, 2 cubed is 8. You can do that on the calculator if you don't know that by heart. Now we're going to solve just like we did the other side. Because we have an x squared, I got to move this 8 over by subtracting. So x squared plus 8x. See, if I subtract, that would be 15. equals 0 because I have to make it equal 0 before I factor. Again, I'm going to give you the opportunity right now. Maybe pause, factor it yourself, see if you know this one, do your X value, do your box, do whatever you need to factor. But when you do your factoring, you should come up with X plus 5 times X plus 3. Meaning that our X values equal -5 and X equals -3. Now, in my calculator, I am going to double check what values come out here. So, -5 squared is 25 plus 8 times -5 plus 23 equals 8. So that works. Let's see, let's check with -3. So 9 plus 8 times -3 plus 23 equals 8. So again, positive numbers inside your log, they both work. So they both are the answers. All right, our last one here. First of all, I see that x 11 to the x equals 30. Those bases don't work very well. Okay, and that's 30 to the first. So I'm just going to look at this base 11. How do you get rid of base 11? You log base 11 both sides. Okay, so then this cancels. So what we're left with is x equals log base 11 of 30. Now, depending on how you want your answers, so if you want exact, I would keep it like that. If we're doing a program where it wants you to do the decimal value, remember we have to use what we learned last time with rearranging logs, and I can go back in my notes and show you this change of base, right? Which is log of x over log b. So that would be log of 30 over log of 11. And then we do that in our calculator. So log 30 divided by log 11. Make sure to close those parentheses of the 30 before you do your division. And then we can round our decimals. I would like you to try to get in the habit of 3 decimal places, because if you ever go on to calculus, that is where they will round to. All right, you're done. Let's try some practice.